Alright guys, so today we're going to be talking about Unit 2, Lesson 1, and this is going to be solving by substitution. So last time we talked about solving by graphing, and the difference in this, guys, is strictly going to be we're doing the same thing without using a graph. So we're going to talk about the steps, which I've given you two different ways to look at the steps, if you can see that on here. The reason I'm doing that is so that y'all can see it in two different ways. Okay, so the first one is just going to be a simplified version, but it doesn't give a lot of detail. So the first step is you're going to solve one equation for either x or y. You get to choose. It's always your choice. Basically, when you do that, then you're going to substitute this expression into the other equation and then solve for the variable that you chose to use. Okay, the third thing is you're going to substitute your answer into the revised equation from step 1 and then solve the other variable. So that's a really simplified version, and that's okay if that makes sense to you, but here's another way if it doesn't make as much sense to you. So basically, substitution, guys, is a method for solving linear equations. So guys, remember, linear is just a line, not going to be anything curved or anything fun like that. That involves solving one equation for a specific variable and then substituting the new expression into the other equation or equations with the goal of eliminating a variable. So we're working with 2x2 systems of linear equations. So that means they have two variables and two equations. The solution to a two-variable system of equations may be represented by an ordered pair. So guys, when I'm saying it's represented by an ordered pair, that's your solution, which is what we did when we did our graphing, which is our x and our y. So the solution we got from our intersecting points is an ordered pair, and that's our solution. So now that we have a base idea of what we should be looking at, we're going to go through these steps. So we've got 5 steps on this one. You isolate your variable. You substitute the expression representing the variable in another equation. We're going to simplify and solve. Substitute the value found in 3 into either of the original equations. See that either you still get to choose to solve for the remaining variable. Write the solution as an ordered pair if appropriate. So using these steps, sometimes it's hard just to look at words. So what we're going to do is we're actually going to look at it step by step. So we have our original equations. Based on just my equations, the easiest one I see already is right here because I have my x by itself. It doesn't have to be divided by anything to simplify. So I'm going to isolate a variable in one of the equations. So I'm going to take my x minus 4y equals 9, that equation right there, and I'm going to just plus my 4y on both sides. So my x is by myself, and I get x equals 4y plus 9. So now I know what x is. It's 4y plus 9. So I can now substitute this x into my other equation. So I can get my 2 times, I'm going to put it in blue so y'all can see the difference, 4y plus 9 minus 3y equals 13. So from here, I can simplify and solve. So the first thing I'm going to do is I'm going to distribute in. So that should get me 8y plus 18 minus 3y equals 13. So then I'm just going to combine like terms. So I've got here and here, my 8y and my negative 3y, and that's going to give me 5y plus 18 equals 13. Then we're going to go minus 18. And that's going to give me 5y equals negative 5. And if I divide my 5 off of my y, it gets me negative 5 divided by 5, which will give me y equals negative 1. So now I have my first term. That's right here. So what I need to do now is I'm going to substitute that value into either of the first equations. So I can choose the first one or the second one. So I'm going to plug in my y for my x minus 4 times negative 1 equals 9. So this right here got put in here. So now I'm going to multiply. So I get x plus 4, because negative times a negative, and then equals 9. So then I'm just going to do x plus 4 equals 9 minus 4 on both sides, and I get x equals 5. So here's my other part of the equation. So that means now I can actually write as an ordered pair, which is going to give me 5, negative 1, which remember our ordered pair is xy. So there's my answer. So this right here, guys, is going through the different steps that we have right here, year 1 through 5, but it's showing you through an example. So now what I'm going to do is I'm going to go through our 4 examples using our different steps. So my first one here, if you'll notice, I have just my x by itself again. So I'm going to use that one first and simplify it down. So I'm going to minus 7y from each one, and then I'm going to get x equals negative 7y minus 27. So now this x can be plugged in for my 2 over here. So I'm going to do it in a different color. So I'm going to have 2 times my negative 7y plus 27 minus 5y equals negative 22. So now I just have to simplify and solve. So I'm going to distribute here, and that gets me negative 14y plus 54 minus 5y equals negative 22. Now I just have to do my like terms. So I've got this one right here and this one. That's going to give me negative 19y plus 54 equals negative 22. Minus 54 from both sides. That gives me negative 19 equals negative 76. Divide negative 19 by 76. And that's going to give me y equals 4. So now I'm going to plug that y back in for my other equation. So I'm going to do x plus 7 times 4 equals 27. That'll give me x plus 28 equals 27, and then minus 28 on both sides. And that gives me x equals negative 1. So that means my ordered pair is going to be negative 1, 4. And that's going to be my answer right here. Okay, so moving on to number 2. So this one's even easier. If you notice my first one, it already has an equal for y. So that means I can plug my y straight in. I get to skip 2 steps. So I'm going to have 9x minus 2 times negative 3x minus 13 equals negative 4. So I'm going to do the same thing. I'm going to distribute. Notice again, guys, that this right here is a negative 2. So it means you have to distribute that negative in. So I'm going to have 9x plus 6x plus 26, because you get negative, 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 and negative, equals negative 4. So combine like terms right here. That's going to give me 15x plus 26 equals negative 4. Minus 26 on both sides. It's going to give me 15x equals negative 30. Divide by 15 on both sides. And I get x equals negative 2. So that's my first one. Now I'm going to take this and I'm going to plug it back into one of my equations. I like the y equals one because it's going to be simple. So I'm going to do y equals negative 3 times negative 2 minus 13. That'll give me 6 minus 13 equals y, which will give me y equals negative 7. So then my ordered pair is going to be my x, which is my negative 2, and then my y, which is my negative 7. And that's going to be my second example. So then I have my third example, guys. So for this one, you notice again it's rather easy because it already has your x simplified for you. So then all I'm going to do is plug that x into the x of the other equation. So that gets me 2 times 5y plus 27 minus 10y equals negative 22. So then now I've got to simplify and solve. So I'm going to distribute my 2 in. That's going to give me 10y plus 54 minus 10y equals negative 22. Well, first thing, remember, we're going to combine like terms. But if you notice, I've got a 10 and a negative 10, which is going to make those cancel, which is going to give me 54 equals negative 22. Well, most of y'all can tell that that doesn't equal, so that can't be true. So when that happens, that means we don't have any solutions, so we can just put our dash right through. We have no solutions whatsoever. Okay, so that one's pretty easy. Now we're going to look at number 4. It says example 2, but it's number 4 on our stuff. And we're going to choose an equation. I like this one strictly because it's already pretty much set up. So then I just have to do negative 2y equals negative 3x minus 4. And I just have to divide by negative 2 all the way across. So then I get y equals 3/2, because I got a negative and a negative, x plus 2. So this can now be plugged in right back to here. So I get 3x minus 2 times 3/2 x plus 2 equals negative 4. So I'm going to distribute my 2 in. That should give me 3x minus 3x minus 3x minus 4 equals negative 4. Well, again, guys, we have the same situation here. We have a 3x and a negative 3x. Those are going to cancel. But it gives us now negative 4 equals negative 4. But those do equal. There you go. Check out. So that means it is a true example, which means our solutions are, we're going to have infinite solutions or infinitely many solutions, which means that they're the exact same line. So guys, that is the 2x2 substitution notes. If you're having any issues, please come into AP.